Math is super fun. Slope is rise over run. I be chillin' in the sun, yeah. Singing math is super fun.
Guys, let's go over the stats quiz number 13, 4-1 to 4-8, taken on May 3rd, 2021. Question number 1, what is the probability of picking an orange marble and flipping tails? So, orange marble, probability of orange and tails. So we're going to find the probability of orange and the probability of tails. And the question we have to answer is, are these events independent? Does picking a orange marble affect flipping a coin? Or does flipping a coin affect the outcome of picking a marble? The answer is yes, they are independent, right? Like one day you move outside your parents' house. If I choose to wash my hands, my parents who live 15 miles from me, they cannot yell at me. It doesn't affect what I do, right? Why is that important to us? Because then this becomes multiplication. So there are 1, 2, 3, 4, 5, 6, 7 marbles, and then there's only one orange, right? So there's 7 marbles times 1 orange. And then on a coin, it's either just heads or tails. So there's 2, our sample space is 2, and then we want tails, which is just one of those. So it's just going to be 1/2 times 1/7, and you can just multiply across, and you will get 1/14 as your answer, which is choice D. All right, question number 2. A card is picked at random from a deck of cards, and after putting it back, another card is picked at random. Are these events independent or dependent? Okay, putting it back means you start with 52 cards in a deck of cards. So first pick, and then your second pick, if you put it back, so you started with 52, take one out, there's 51, but you put it back, there's still 52 cards. So that means this one is still 52, which means our second pick is not affected by the first pick because there's still 52. So in this case, they are independent. Let me just write this out so for those who kind of get stuck on this one. If I said, if I said the first pick, there were 52, and then I like to call it where you eat the second card, or you eat the card that you picked, which means there's only 51, then that would be dependent. Why? Because if, say, you pick a king. There's 4 kings in there, so that would be, say, 4 out of 52. So picking a king and a king. Then the second one, let's just say assume that the first one you do pick it, but there's only 3 kings left. But here's the big idea here. There's only 51 cards left. Okay, this one would be no replacement. This one would be replacement, which is our event. This would be 4 out of 52 for the first card for a king, and then 4 out of 52 because you replaced it. Okay, part B. A marble is picked at random. Without putting the first marble back, another marble is picked at random. What's the probability of getting yellow and then red? So this is the first pick, and this is the second pick. Okay, the first one, the probability of getting yellow, let's just count them all up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The probability of a yellow is 1/10. Okay, let's figure out without putting the first marble back. So that means there's how many marbles now? There's only 9 marbles left. And then we want the probability that it is red. So the probability that it's red, there are 9 of those. So that's kind of unusual, right? You're gonna get a red marble the second time. So if you these events are again independent. I'm sorry, it is dependent on the first one, but you can still multiply these. Because this one, it doesn't really matter. 1/10 times 1 is just 1/10. Now, it wants it as a percent. So, remember a decimal, and then as a percent, you would multiply that number by 100, or move that to the two spots. Give you 10% as your answer. Okay, let's go on to the next page. All right, question number 3, two-way table. The question, do you play football, was asked of 110 students. Results are shown in the two-way table. So remember, they already added down, and they also added across to give us the totals. Okay? Drag the response to answer the questions. Question number 1, let's just go ahead and I'm going to number these. This is question number 1, 2, 3, 4, and 5, and this is choice A, B, C, D, E. Okay, what's the probability of randomly selecting an individual who is a boy and plays football? So how many people are we picking? We're just picking 1. So that means there's a total of 110, and then a boy. Go ahead and erase all of that. A boy and plays football would be 42. 42 out of 110 gives us 38%. So this one would be choice A is our answer. Okay. B, what is the probability of randomly selecting an individual that is a boy? So just selecting one person. This is out of the total. And I'm selecting just a boy. So boys are total of 75. So 75 divided by 1. 75 divided by 110 gives me 0.68. And that'll be choice D. All right, next one. What is the probability of randomly selecting an individual that plays football? So again, I'm selecting out of everybody. And football is here with their total 54. So I'm going to do 54 divided by 110. This will give me 49. And 49 will be choice B. If you randomly select a boy, so here's the conditional. So probability that it's a boy, and we already have that from above. So there are 75 boys. What is the probability that they play football? So looking at just the boys, let's erase all this. What's the probability given a boy, so out of 75, so looking at this row, who plays football? That would be a 42. And this would give us 42 divided by 75.56. And 0.56 is choice C, the third tile. And if you randomly select a football player, okay, so this one is saying the given now is the football player. And how many people play football? I can use the number from above, 54. What is the probability that they're a boy? So let's look at football players. Plays football here, and then from here, how many are boys? Well, that would be 42. So 42 divided by 54 will give us 0.78, which is choice E. Okay? All right, let's do the next one. Venn diagram. B is the event that student rides the bus, and L is the event that they buy lunch. Okay, so let's make sure we read this together and just hope you understand the Venn diagram. The probability that someone rides just the bus only would be 0.19. The probability that they just ride the bus in general is going to be 0.19 plus 0.38. Remember, that's a total, so the probability that someone rides the bus is you're adding those two. Guess I should have done that in yellow, right? In green, the probability that they eat lunch only is 0.16. And then remember, together, it's because it's a big circle, right? It's 0.38 plus they read lunch and the bus. 0.38 plus 0.16, whatever that is. Okay? All right, let's answer these questions. What's the probability that a randomly selected student rode the bus and bought lunch? Okay, so remember, probability of bus and, guys remember that little trick? Well, that is called the intersection. The intersection is 0.38. This is, in here, someone who rides a bus and buys lunch. Okay. What is the probability that a randomly selected student rode the bus or bought lunch? Remember, or is a plus. So we needed the probability of the bus plus the probability of the lunch, and then we subtract those that are both, because you can't double count them twice. So probably bus and lunch. So probability of a bus is 0.19 plus 0.38. And then the probability of lunch is 0.16 plus 0.38. But what did you guys notice in that? You're counting 38 twice. That's why I'm subtracting from the problem above, 0.38 bus and lunch. So I get 0.19 plus 0.38 gives me 0.57 plus 0.16 plus 0.38 gives me 0.54. And here should be your caution why you have to subtract. If you added 57 plus 54, what happens? You get 1.11. Can you get something over 100%, 111%? No. So that should kind of tell you that you need to do something. In that case, subtract 0.38. Then your answer is 0.73. And the last one, what is the probability that the selected student did not ride the bus or buy lunch? Okay, so that would just be outside the sample space, right? No bus, no lunch. That would be right there, 0.27. Okay, so that's Venn diagrams. Again, you could, if you wanted to, you can do a Venn diagram to do a two-way table. I just want to quickly point this out. Lunch, yes and no. So someone that does both yes, no, bus. So the no's would be 0.27. The yes is what they have in common, 0.38. Yes, bus, no, lunch would be 0.19. And yes, lunch, no, bus would be 0.16. So if you add those together, you would get 0.54. This one you would get 0.46. Can I write out there? Oh, I can't. What a bummer. Okay, 0.57. And this would be 0.43. And then if you add those in blue, you would get 100. And in black, if you add those together, you get 100. Okay, so that's how you would do it on a two-way table if you don't like the Venn diagram. Question number 5, to make pizza, I want to pick one type of crust, one type of sauce, and one type of topping. There are 3 crusts, 3 sauces, and 9 toppings. How many different pizzas can we make? Okay. So essentially here, we have 1 crust, 1 sauce, and we have one topping. Now, if you think about this, does order matter? No. So you can kind of pick, you can use combinations, but this is just easiest. They want how many different types. Again, this is not permutations because permutations order matters. I don't really care how you pick them. You're just going to have 1 crust, 1 sauce, 1 topping. In addition, you can also do of the 3 crusts, you're choosing 1. 3 choose 1. And so in the crust, you would have 3 options. And in the sauce, you would have 3 options, 3 choose 1. And then same thing over here. For the toppings, you would have 9 choose 1. And if you multiply those together, you will get 81 toppings is your answer. Now, this is not talking about a specific probability or choice. There's just kind of like what's the total. So that's how I see it, total. Okay. Number 6. Tim's MP3 player has 100 songs on it. Of those, 60 choose hip-hop, 10 are rock, and 30 are rap. The MP3 player is set to random, and once a song has been played, it cannot be played again. So replacement or no replacement? No replace. What's the probability that the first song he listens to is a rap song and the second song is a hip-hop song? Enter it. The answer is a fraction in simplest form. Okay, this is starting to get complicated. So one way you can do kind of like a semi-medium problem complicated is use a what? Tree diagram. So let's do a tree diagram. Okay, point. So 60 out of 100, I'm going to call H for hip-hop. This is going to be, you could just write that, 60 out of 100. Okay, then a rock music is 10 out of 100. And then if you choose rap, this is going to be 30 out of 100. Okay, this is the only part that changes here. So in the first song, let me write that above. First song, you have how many choices in this branch? I'm going to circle something in, right? So this is my first branch. How many songs do we get to pick from? 100 songs. But on the second song, what happened? No replacement, so there's 99 songs to pick from. Does that make sense? Okay, so from this branch, if you choose the second song, if you choose hip-hop, then you will have picked, how many choices are left if you picked it previously? this would be 59 out of 99. Because you're assuming that you've picked it. Yeah, you've picked hip hop, so there's from instead of 60, there's now 59. Instead of 100, you're in the second song, there's 99. Okay, now pay attention. For rock, you didn't pick rock in the first one, so that would be 10 out of 99. And then rap, you would have 30 over 99. Okay? And we're pretty much going to do that for each branch. Okay, for rock, it is now hip hop. There is a, what? 60 out of 99. Okay, for this branch, because we picked rock in the first song, that means the second chance there's only 9 songs to pick from out of 99. And then from here, rap, you have 30 out of 99. Okay, so basically the denominators of my second song are all 99. And in each of these kind of like sections, the only one that goes down by 1 is the one that was picked previously. I don't know if that helps or not. So again, let me try on this one. The first one was red, right, in rap. So that means the only one that has red is going to go down by 1. So there are 60 songs to pick from. For hip-hop, rock, there were 10. Okay, here it is. Here's red. And now I have to go down by 1 because the first one we had picked it, and now there are 99 songs. Okay, now I'm going to color code this. Okay, it says first song is rap. So I'm going down with this branch, okay? And then the second song is hip-hop. Okay, so that should help you identify what our probability is. So 30 times 100, 30 over 100 times 60 over 99. Because this is the probability of getting, what is it, rap, and the probability of getting hip-hop. And the notation really of that is probability of rap times, and that's conditional probability of hip-hop given rap. Okay, so this one says as a fraction, so I'm just going to break this down. 30 is 3 times 10, 100 is 10 times 10, 60 is 6 times 10, and 99 is 3 times 11. So I'm going to cancel my 3's, I'm going to cancel some 10's, 10 divided by 10. Whoops, I see my mistake, this one. You could have done maybe 9 times 11 or 3 times 33 is my mistake. So then we're left with 6 out of 33, which is 3 times 2, 3 times 11. So my answer is going to be 2 out of 11. So 2 11ths is my answer.
Math is
those are the solutions for
super
quiz
fun.
number 13. We'll see you guys.
Slope
Bye.
is rise over run. I be chillin' in the sun, yeah. Singing math is super fun. Math is super fun. Slope is rise over run. I be chillin' in the sun, yeah. Singing math is super fun.